I divided our lecture on sediment flux through the ice marginal land system into two sections, of which this is the second one. So you might want to make sure you've watched part one of this before moving on to this second part, in which I'm going to talk about a research case study looking at debris flux through the ice margin at the Russell Glacier on the west margin of the Greenland ice sheet. So this case study is based on work that a variety of staff from Kiel have been working on over many years or decades now. I'll put references for some background reading if you want to follow this up in your reading list. But over many years we've been looking at the origins of debris within the ice, how the glacier picks up the sediment and how that forms the basal ice layer of the glacier. In particular, we've been looking at the flux of debris through the basal ice layer and also looking at how the signature of the basal ice is preserved in post-glacial sediments as a kind of memory of the glacier left behind in the landscapes and sediments that survive after the glacier has gone. As part of that, we've been analysing the ice itself, the debris structures within the ice, the sedimentology, the crystallography, the isotope chemistry, and the landforms, the moraines themselves. So I'll put some reading that you can do on that into the reading list if you want to follow up more details. In particular, I'm going to pick up a question that we left off the end of our previous session on, which was, well, what is the annual flux of debris through the ice margin? How would you measure that? So we're talking about the fact that glaciers produce debris. They release that debris into the proglacial environment. Some of it gets stored at the ice margin, for example, in moraines or in ice marginal lakes. And some of it, either immediately or after a delay, is released into the distal proglacial environment. So there's a paper here. It says quite long ago that we did this work, but it's a nice case study for what we're talking about in this session. This paper by Knight et al. 2002 in the Journal of Glaciology will give you some of the detail of what we're talking about. And what we found when we were doing this work is that a high proportion of the debris being released through the section of the ice margin that we were looking at was coming through the basal ice layer. Now that isn't typical of all glaciers, and in some other environments most of the debris comes through in water, for example, being released from the glacier. But that wasn't the case in our particular environment, and what I'm going to explain to you over the next few slides is how we found out where the debris was coming from and what we discovered about this particular ice marginal environment. So what did we actually do? And the first step was to quantify the basal ice facies sequence. In other words, what kinds of basal ice were there at our stretch of margin and what was the characteristics of the debris within that sequence. So here's a picture of the front of the glacier. Person there for scale, and you can see that there are different layers within the basal ice with different amounts of debris, different crystal structures, and so on. We'll go through this in more detail next year, those of you that do the glaciers module, but for now simply recognize that there are different facies or different types of ice within the basal layer, and that those different ice types or ice facies have different concentrations of debris within them. You can see that a little bit more clearly here with a close-up of one of the debris bands, and here's a longer view of those debris bands in context, and here a close-up of a bit of ice from what we call the dispersed facies, which is the cleaner layers of basal ice in between the debris bands at this particular site. So what we would do in this situation is measure the debris concentration within each of the facies. So per cubic meter of ice, how many cubic meters of debris would you expect to find, for example. We then measure the thickness of each of the facies, so we know what the basal ice layer is actually composed of in terms of how much stratified, how much dispersed, how much thickness of debris bands, etc. And then we'd explore the ice margin, mapping the distribution of the different facies and the different facies sequences. From that, we would be able to work out how much debris was present at the ice margin in the basal ice layer for each meter of the ice margin. Here's a picture of us underneath the glacier in a cavity at the margin. This was in the days before health and safety and hard hats and all that kind of thing, but here we are underneath the glacier, hacking away at the ice, trying to excavate debris bands to measure the debris concentration within them. The next step of the exercise is to survey the glacier itself repeatedly to see how it's moving over time. So we set up markers on the ice surface and at the front of the glacier, and we measure their position as the glacier moves over the course of time. So having done that, we now know how much debris there is within the basal ice, and we know how fast the glacier is moving, or how far the ice is moving forwards during the course of each year. Also, as part of our surveying or measurement program, we need to measure the advance or retreat of the ice margin and any change in thickness of the ice close to the margin. The reason we need to do this is that suppose we found that the ice was moving at 10 meters per year and the ice margin was advancing by 10 meters per year. Well, that would imply that there's no ice actually being released or lost, and no debris being released or lost into the proglacial environment, because the movement forwards of the ice is being accommodated by movement forwards of the margin, and the glacier is simply expanding. But suppose we found that the ice itself was moving forwards by 10 meters a year, but the ice margin was staying in exactly the same position. Well, that would imply that in order for the margin to stay where it is, that 10 meters forward movement of ice must be being accommodated by loss of ice and therefore release of that much debris into the proglacial environment. If the ice was moving forwards at 10 meters a year and the ice margin was retreating at 10 meters per year, well then from that we'd work out that the equivalent of 20 meters worth of ice and the debris associated with a 20 meter thickness of basal ice layer or length of basal ice layer back up into the glacier was being lost. So we need the volume of debris per unit of the basal ice layer, the rate at which the ice is moving, and the rate at which the ice margin is advancing, retreating, or if it's staying stationary. With that information, we can work out the debris flux through the ice margin. In other words, how much debris is actually being churned out of each meter of the ice margin, or over a 100-meter section, or over a kilometer section, how much debris is actually being produced during the course of a year. And you might just want to pause the slides here, pause the video here, just to make sure that you're understanding how this calculation has worked. What we calculated for our particular site was that the debris flux through the basal ice at the margin of the Russell was varying a little bit from place to place around the margin, but of the order of between 12 and 45 cubic meters of debris per linear meter of the ice margin per year. And you can then compare that with other sites and other types of ice margin at different locations. But where does that debris actually go? Where does it end up? Is it going straight into the ocean? Is it all going into a moraine? Is it all being carried away by the river? That was the next part of our question. And here's a sketch map and a photo to remind you of what our environment looked like. So in the photo here, we've got the glacier coming down the valley and terminating with this lake in the front of it and a moraine, and then the river going around the front of the moraine. And you can see that on the map. Here's the edge of the glacier in the bottom right of the map. Here's a 1968 margin we got from Air Photos. Here's a 1999 margin, which was one of our survey dates. And around that 1999 margin is the ice marginal moraine. And you can see that in 1999, the ice was actually up, climbing over parts of that moraine and sitting on the crest of the moraine. At other points during over the years when we've studied that location, this was back in the photo was back I think in 1984 I think, and in that at that time you can see here the glacier is way behind the ice marginal moraine, not far away from where the map shows it to have been in 1968. And then between the mid-1980s and the 1990s, the glacier advanced, and in places advanced right over the top of this moraine. And one of the points I want to explore is how the position of the ice margin relative to the moraine makes a big difference to where the debris goes when the ice lets go of it. So here are some cartoon cross-sections of different situations that help you to see where debris being released by the glacier would end up. So here's the surface topography. So here's the proglacial moraine, and here in stage A, the glacier is sitting well behind that moraine. So any debris which is released from the glacier here, from the front of the glacier, is likely to be put into storage, being trapped between the front of the glacier and this moraine. You might expect there to be lakes, for example, in this area, or other sediment storage locations, or the glacier would simply be pouring debris out or releasing debris onto that proximal, the near glacier side of the moraine. Likewise here in section in stage B, the glacier is approaching the moraine, but still there's opportunities here for storage in this proximal side, this proximal zone between the glacier and the crest of the moraine. And again, you'd expect there to be opportunities for the formation of lakes and other sediment traps or sediment stores in that environment. As we move forward towards stage C, though, where the glacier has advanced and is now overtopping the moraine, certainly any debris which is being released from the front of the glacier rather than being released at the base here, anything coming out at the front is likely now to be released onto the distal side, the far away from the glacier side of this moraine, and therefore be much more likely to be carried away by gravity down the moraine slope away from the glacier, or by meltwater away from that slope away from the glacier and into the distal proglacial zone on the far away from the glacier side of the moraine. That's true also in subsequent stages as the glacier continues to override this moraine. And also what we discovered is that as the glacier is overriding the moraine, subglacial entrainment leads to the cannibalization of the material within the moraine. The glacier entrains material from its own moraine that it's riding over and releases that into the proglacial environment. So as the glacier advances further and further through stages E and F and overrides that moraine, the moraine gets cannibalized. The debris from within the moraine gets recycled and put forward into the proglacial area. So having observed those different stages, we plotted on this model graph through the stages A, where the glacier is well behind the moraine, through to D, E and F, where it's overtopping the moraine and overwhelming the moraine. We modelled how much debris you would expect to be seeing at different stages through that transition. The dashed line in the middle of the tree at the left-hand side, that dashed line represents how much debris is being produced into the distal proglacial environment directly from the glacier itself. And at stage A and at the beginning of stage B, not much at all is going to make it through to the proglacial environment because a lot of it gets trapped within and behind the moraine. But then as you move forward into stage C, and from then on, then you have a much higher amount of debris being released from the glacier directly into the proglacial zone, and therefore making its way away from the glacier. The dotted line at the bottom of the tree here, that's the debris which is released by cannibalization and recycling, if you like, of the moraine. And in stage A and stage B, that moraine is sat there quite happy, not being disturbed. Then during stages C, D and E, that moraine is progressively demolished, overridden, re-entrained, recycled, and the debris from it is pushed out into the proglacial environment. By the time you get to stage F, most of the moraine has been recycled, or at our location, most of the moraine have been recycled, and so the amount of debris being produced drops off, and we have this peak, this short period during which extra debris is being produced because of the recycling of the moraine. The solid line then is simply the sum, the cumulative value of how much debris is being produced over time as that moraine is overridden. And you can see at the end of the time period, more debris is making its way out into the proglacial environment because we no longer have the moraine holding it back. At the beginning, the moraine was holding lots of debris back, and the spike in the middle here is because there's that short period where, as well as the glacier producing its regular amount of debris, it's also recycling that debris that was previously held in the moraine. And this view shows the ice margin, or part of the ice margin, close to the area where we were doing that work. And in this location, you can see the ice margin riding up the inland side of the moraine, overtopping that moraine, and just reaching a position here at the right-hand side of the picture where it's beginning to overtop and send water and debris down the distal side of that moraine, so that this debris, this fan of debris here, being coming out with the water and going out into the proglacial river system. Whereas back here in the background, that isn't yet happening so much, and in this location, more of the debris will be being preserved back on the proximal side of the moraine. You can also pick out in this picture, which I think I mentioned in the earlier session, the current modern present day active moraine, and you can distinguish that from this ancient moraine, which just happens to be in a position where the current glacier and the current moraine, the current glacier is about to advance over all of this, but this is an older moraine relating to an earlier stage of the development of the ice sheet. There are lots of interesting things in this photo for you to think about relating to other parts of this course. Here, the scree slope with the bigger boulders down the bottom and the finer boulders at the top. If you went down and explored this fan, you'd find it to be the other way around, with coarser grain material at the top and finer grain material at the bottom. In any land system or in any landscape, there are always lots of examples to look for that illustrate things that we've been talking about at different stages in the course. So keep your mind open and keep thinking broadly about all the different themes that we're covering in this module, and try to look for examples or illustrations of those throughout. So one point that arises from this relates to our question about the boundary and the extent of the ice marginal system. So at stage A, for example, you might argue that the ice marginal land system really just belongs in this area here, because there's not a great deal of contact between the glacier and the distal proglacial environment, because so much of what's going on is being constrained within this proximal side of the proglacial environment. If you follow that line of reasoning, then the extent of the ice marginal land system would be shrinking as the glacier advances towards that crest, but then would expand again as the glacier overwhelms the moraine and opens up this whole distal proglacial area as being now directly connected to the front of the glacier. That is only one way about thinking about the definition of the ice marginal system's boundaries, but it illustrates this idea that I want to emphasize about everything depending on everything else and things changing through time. There isn't necessarily one answer to that kind of question that is going to be true in all environments, or even for any single location. Your answer isn't necessarily going to be true for all times, because things change from time to time as things move around. That's what geography over the course of time is all about. And of course, when we're talking about the ice marginal land system and where its boundaries are, it's important to remember that this particular land system is itself a boundary. We're defining the whole land system in terms of it being at the crossover point, at the boundary, at the transition zone, whatever you want to call it, between a glacial environment and a non-glacial environment, the glacier system and the non-glacier system. This picture is obviously from a different location. This is Chimborazo, a volcano in Ecuador, very close to the equator. But it shows very nicely what we're talking about. We have a glacial part of this environment, we have a non-glacial part of the environment, and if we're trying to identify our ice marginal land system, well, the whole land system really is defined as being the margin between this bit, which we know what that is, that's a glacier, and this other bit, well, we know what that is, that's not the glacier. So the ice marginal land system is slightly different from some of the other land systems that you'll be considering in this module, because it is itself a boundary. Now, we'll say more about that next year, those of you that want to follow up thinking about glaciers. We'll talk about the glaciated landscapes and glacial land systems in more detail. And there are a couple of modules that those of you who are with me at Kiel might want to think about. For the sciencey perspective, if you like, then there's a module on glaciers and glacial geomorphology. And if perhaps earlier in this pair of sessions you were thinking that you quite liked those other questions that I offered you about, well, what would it feel like to be in this environment, and how are what kinds of other ways might you engage with or relate to a glacial landscape other than or as well as through the science? And for those kinds of questions, then the inspirational landscapes module might be something that would appeal to some of you. But for now, I hope that this illustration that we've just worked through of debris flux through the ice margin in West Greenland has at least given you something to think about in the context of our broader consideration of sediment fluxes and the nature of geomorphic process environments.